Very good day to all of you. In today's lecture, we will be discussing about second law analysis and its application. So this module specifically covers the application of second law analysis and its application mostly for the thermodynamic process. This lecture is basically taken from all the slides, and the content is taken from Professor Idus Angel's presentation. I acknowledge the whole work is inspiration from his slides. Thank you, Professor. The outline of the presentation will be focusing on the difference between first law and second law. Then we will try to define what is meant by exergy, and then we will see how exergy can be applied for a thermodynamic process, and we will try to define what is the second law efficiency. And before going into that, we should first understand the fundamental difference between first law and second law analysis. In the case of first law, basically we are concerned about the quantity of energy, which is in terms of how much units of energy is getting produced. Let's say it's 50 kilojoule or 30 kilojoule. We are very much concerned only on the quantity rather than the quality in the first law. So it's basically a physical, it is considered as a physical quantity. Energy is treated as a physical quantity in the case of a first law. And in the case of first law, we treat all the energy as same, irrespective of mechanical, electrical, chemical, or thermal. And then we assume that the quantity of the energy is conserved. And this first law is used to apply the energy balance and energy efficiency of the process. It basically gives us what is the energy input, what is the energy output, and how one form of energy is getting converted. It talks about energy conversion and it talks about energy flows only. And normally the first law is just one side of the process, and this does not talk about the other side, which second law will address. And this first law is basically perceived by five senses, which we already understand the first law very clearly. And this first law is not that complete when compared to the second law. In the case of second law based analysis, we focus more on the quality than the quantity. But again, quantity is also important, but we give more importance to the quality of the energy produced. And here the energy there is a difference between each forms of energy. Mechanical is different, electrical is different, because we express in terms of exergy. So mechanical exergy is different, electrical exergy is different. So likewise, so there is a fundamental difference between each forms of energy, and it is considered as non-physical quantity. And all the energies are not equal. And during the process of energy conversion, the quality diminishes actually. Whenever there is an energy transformation happens, the quality diminishes, therefore, which cannot be perceived by five senses. And basically, the exergy analysis deals with inefficiencies of the system, and then it tries to quantify what is the waste occurring during the process. In that way, there is a fundamental difference between first law and second law analysis. And exergy is basically a thermodynamic property that combines the quantity as well as quality. Remember, we combine quantity also as well as quality also. Quality in the sense, how good that energy is, it available for work, whether it can produce less environmental impact, whether this energy is sustainable, whether the energy is available for a full conversion. So in that way, exergy is measure of available energy. Exergy is a measure of available energy, and exergy is a measure of work potential of the system. And it is a measure of sustainability. It is a one step ahead. We can say exergy is basically a measure of sustainability level, because these days we are very much concerned about better optimum resource utilization and waste minimization. So when you account for the second exergy analysis, basically we are finding out how close the system is towards sustainable. So we are trying to minimize the waste and better utilize the resources. And basically it is a entropy production is also accounted, then it decreases the amount of energy that can be used. And exergy destruction is a measure of imperfection associated with the process. So in the case of exergy analysis, we calculate what is the exergy which is destructed, or exergy which is produced during this process, how much exergy is destroyed during this process. With the help of exergy destruction, we can try to find out how much energy is not available for the conversion, and then we can also try to minimize the entropy generation during this process. And then normally when you see the energy transformation happening, you will find that there is when heat transfer happens, it is always accompanied by temperature change. If there is a T1, and then you can see when it undergoes a heat transfer process through a wall, you can see the temperature change is happening. And when there is a temperature change, there is a energy is conserved during this process. Energy is conserved in the sense the total amount of energy which we give into the system will be same as the energy which is coming out of the system. That is, the total energy remains constant. Whereas in the case of exergy analysis, we assume that the entropy is generated during the process, because with the help of exergy analysis, we try to account how much energy is unavailable. So basically, there will be entropy which is generated during the energy conversion process. So we'll try to find out the entropy generation. Also, we will try to find out what is the exergy destroyed. So remember, when there is a energy transformation happening, we assume that the energy is conserved, there is an energy which is generated, and then there is an exergy destroyed. In the case of energy transfer by heat, the exergy transfer by heat is given by 1 minus T naught upon by T into Q. So this is the amount of energy which is actually released by heat, and this is the amount of energy which is released by entropy actually. So which is Q by T1 stands for the entropy transfer. So now let's go into the implications of second law. Basically, we can do the energy analysis simply provides the efficiency of the system. It does not understand where the losses are taking place, whereas with the help of exergy analysis, we can find out the places where the losses are happening. So in fact, it will be very beneficial if you do both exergy analysis as well as the energy analysis. In the case of advanced exergy analysis, we can find out which particular component is having more losses, and indirectly it also helps to find out the entropy, how it can be minimized and how exergy can be maximized. So that is the advantage of advanced exergy analysis. And exergy computation is a tool which can help to rank the different energy systems, how these systems rank and how these systems can perform certain tasks. Let's say example, let's say it perform a heating task or cooling task or power production. In that way, we can find out how these systems can be ranked together. Basically, second law efficiency is a process which is considered as a measure of perfection. You want to find out whether the process is very perfect, then we can do the second law analysis. And with the help of second law analysis, we can see how the process is very close to perfection. If the process is very close to perfection, there will be basically no entropy generation. There is no entropy, there is no exergy destruction, there is no waste generation. Entropy is the one which is causing a lot of, this is a degree of disorderness. This is the energy which is not available for useful work. It is not available for the useful work. And then normally we expect the process to be very perfect. But something which cannot be more than perfect, we give a limit to it. We need to find out upper limit of efficiency. For that, the second law helps us to know what is the upper limit of the exergy efficiencies. And the aim of the second law is basically towards finding out the perfection and then going for a zero waste process. So that is a major scope of the second law. There are fundamental primary applications of the second law. Basically, it is used to find out the quantity of the system as well as quality. It helps to find out the direction of the process. It helps to find out what is the degree of degradation in a process. It helps to find out what is the theoretical limit on the of the engineering systems. It can find out what is the causes, what is the reason for the thermodynamic losses in the system. It also helps in improving and optimizing the design. So all the thermodynamic designs can be improved and optimized with the help of the second law efficiencies. It also helps to find out where is the point at which there is a efficiency loss, what is the place, how much is the quantity, and all these things can be quantified. Once you find out what is the losses, we can also take steps to reduce the losses. In that way, exergy analysis is the one which helps us to understand what is the internal exergy destruction happening in the system. At the same time, how much is the external exergy losses which is happening to the surrounding. So with the help of second law of analysis, we can try to go towards a greener thermodynamic process. That is the main objective. And you know that for a thermodynamic system, we have a high temperature reservoir and low temperature reservoir. And for that, if you want to find out the efficiency of the system, normally it is expressed as 1 over T upon L by TH. If you see with increase in temperature, the efficiency is better. But when you go down, the temperature is with the efficiency is decreased. So basically the temperature of the source plays a very important role. So this determines the quality of energy also. If you have a source at a very high temperature, then naturally we will have a better quality of energy. So basically this is the one major limitation with the second law, which states that higher the temperature, higher will be our energy or exergy performance of the system. And finally, we can relate all these things together. Energy is the one which is always conserved during the transformation, and exergy is the one which is always destroyed during this process, and entropy is the one which is always generated during this process. In that way, energy is conserved, exergy is destroyed, and entropy is always increased. So this is the fundamental theory behind the second law of thermodynamics. If you understand all these fundamental concepts like entropy, exergy, second law analysis, we can find out, we can design a greener process and a greener thermodynamic system. So this will be the application of the second law analysis. That's all for this class. Thank you.